Hey guys, this is just a video on the solution for question 3 from the second coursework. In this question we have two cyclic groups. The orders of them are coprime, and we have to show that their direct product is also cyclic. Okay, so what do we do? Well, let's write down a generator for A and B. Let's suppose that A generates A, and B generates B. So like the order of A is M, the order of B is N. Okay, now one way to do this is just to kind of write a generator for A cross B. So this generates, we're going to say that the ordered pair A comma B generates the direct product. Okay, so how do we prove that claim? Well, one way is we can compute the order of A comma B, or we could prove that any an arbitrary element of A cross B is just a power of A comma B. Let's do it that way. Okay, so an arbitrary element of A cross B can be written as, well, an element of A is like some power of little a. So you could write it like, let's say A to the R and B to the S. And we have to write, you must solve for L. We must solve for L A comma B to the L equals A to the R, B to the S. In other words, we have to solve A to the L equals A to the R, and B to the L equals B to the S. Okay. And that might seem hard, but remember that we can kind of rewrite this A to the R, right? We can rewrite it as, just remembering that A to the M is the identity. We can rewrite this as A to the R plus, let's say, MX. And we could rewrite this as B to the S plus NY. Okay. Or using this, we know that B to the L minus S is the identity, which means L minus S has to be a multiple of N, L minus R has to be a multiple of M, and that gives, that's probably a better way to state it, but in any case we get L equals S plus NY, and L equals R plus MX. We have to solve this. So let's, these are the same L, so let's solve S plus NY equals R plus MX. Okay, and S and R, N and M are given, and we have control over Y and X. Okay, so let's start by rearranging. We get S minus R equals MX minus NY. Okay, but the GCD of MN is 1, so we can write M, I'm running out of letters, but maybe like MU plus NV equals 1. Well, if MU plus NV equals 1, then MU times S minus R um, minus n v r minus s equals s minus r. The minus sign comes from just that r minus s is negative s minus r. Okay. So, therefore, I'm able to solve this equation. My solution is, this is x, this is y. Okay, I'm able to solve this equation. Well, now, let L just be s plus ny, where y is this, which is equal, by definition, that's equal to r plus mx. And now look, well, a comma b to the L, let's just a to the L, b to the L, well, let's just a to the s plus ny, b to the r plus mx, but b to the mx is the identity, a to the ny is the identity, since a to the n and b to the m are both the identity, so this is just a to the s, b to the r, which was my arbitrary element of a cross b. So now we conclude that a comma b generates a cross b. The n, of course, that's not the only way to do this question. A lot of you probably know that. If you have any questions about that solution or a different solution, you can please email me. Thank you.